Every transaction ID you have ever seen on Etherscan, every contact address, every block, they are all just hash output. You don't need to be a developer to understand what that means. But if you are doing on-chain work, if you are in the Web3 space, you are missing something foundational. So in this video, we will try to learn what hash functions are, how they work, and the key properties that makes them essential in cryptography and the overall Web3 space. Okay, so the first question, what is a hash function? To answer this, you can think hash function like a machine. Okay, so it takes an input and it gives us a fixed length output. So it can take a word, a file, or an entire blockchain block as an input, and the output will be always a string of fixed length depending on the type of hashing algorithm that we will use. There are different types of hashing algorithm. We have MD5, which always produces a 128-bit hash. It was once widely used, but today it's considered broken. Then we have Blake. There are actually different versions of Blake, like Blake 2, Blake 3. Then there is another algorithm named Secure Hash Algorithm, which in short we call SHA or SHA. It has also different versions, one of which is SHA-256, which is widely used in blockchain and cryptocurrency space. Bitcoin uses SHA-256, Ethereum uses Kachak-256, which is a variant of SHA-3 family, and they both generate 256-bit hash. Here you can see an online Kachak-256 hash generator. As you can see, if we enter different length of inputs, it always generates a fixed 256-bit output. You can notice an interesting pattern here. If we change a single digit, the entire output changes. This is called the avalanche effect. One bit of difference results in an entire different output. This is why you can't reverse it by brute forcing small variations. The output gives you nothing about the input's structure. This property is known as pre-image resistance. There is also another interesting property which is known as second pre-image resistance, which is simply that no two different inputs can produce same output hash. So if you have any hash, it's always linked back to a single input. This means our hashes are also collision resistant. A collision happens when two completely different inputs generate the same hash, and this is mathematically possible because the number of possible output size is always fixed. So collision can exist mathematically, but our modern hashing algorithms are computationally difficult and making the collision effectively impossible. But there are older hashing algorithms such as MD5 in which collision exists. Now in Web3 space, we are always using hash functions knowingly or unknowingly. Our wallets use hashing during address generation. Smart contracts uses hash for commitments, randomness, signature verification. Even transaction IDs are simply hashes of transaction data. Thanks to deterministic properties of hash, nodes verify blocks independently without talking to each other. Without cryptographic hash functions, blockchain couldn't guarantee integrity or detect tampering. And that's the basic of cryptographic hash functions. Once you will understand hashing, many concepts in blockchain and cybersecurity will start to click. Thanks for watching. I'll see you in the next video.